Okay, what I'd like to do is review a little bit of the stuff before we go on to more advanced circuits and talk about where we are with our circuits up to session 3. The first thing I want to do is describe a little bit of the difference between the low power bus, which draws its power off the Arduino or off the USB port, and the high power bus on this side, which draws its power off of our battery pack, or could actually use any DC supply. And it doesn't have to be 5 volts. So we could drive larger motors and so on off of it. Note that our battery pack is attached, the positive is attached to the red bus line here, and that the negative or ground of our battery pack is attached to the blue bus on this side. The other thing to note is that the two negatives, the negative on the high power bus and the low power bus, are connected together. See this green wire in here, connecting the minus on this side to the minus on that side. And that's so that the base state, the 0 volt side, no matter whether we have 5 volts coming in here, 6 volts coming in here, 12 volts coming in here, or whatever, that the 0 is the same on both sides. So the ground has to be the same. That's why we need to have a green wire connecting the ground on the high power bus to the ground on the low power bus. Okay, so again, our high power bus draws power off of the battery pack, and the low power bus will draw power off of the Arduino, which will, at least while we're hooked up, draw power off of the USB plug in your laptops. Okay, just to review now. The first circuit that we looked at was an LED circuit, and an LED circuit, you recall, we are limited in the amount of current that we can put through our Arduino as an absolute maximum of 150 milliamps, but we really don't want to get close to that if possible. So each LED draws about 20 milliamps, and so what we've got here is we've got our PWM, our pulse width modulated circuit connected to pin 9, okay, which will send a pulse out, a 5 volt pulse out to the LED, and when it goes through the LED, it then goes to ground through a resistor. You must have a resistor in there, otherwise your LED will be way too bright. You have much more current flowing in it through it than 20 amps, and you'll blow out the LED, and you might even blow out the Arduino, which we do not want to do. Okay, so then what we're doing now is we are just powering this LED through this resistor, and the resistor can be any value, from about 250 ohms all the way up to 1,000 or 1 kilo ohm. 1 kilo ohm, of course, having a lot of resistance to it will mean that the LED is fairly dim, and 250 ohms will have very little resistance to it, which means the LED is fairly bright. Bright LEDs draw more power, of course, than dim LEDs. So you want to make sure that your circuit is such that you can see when the LED is on, but you're not drawing too much power through the Arduino. Notice that this is connected to the Arduino, okay, and then it's connected to ground, and it's in the PWM circuit, the pulse width modulated circuit, which we can chop and send varying amounts of power through that circuit using our software to control the LED. That was the first thing we did, is look at LEDs. The next thing that we did was we looked at analog devices, and we were using the CDS cell, the light sensitive resistor, or a thermistor, which is a temperature resistant thermistor, in what's called a voltage divider circuit. And on a voltage divider circuit, we have one leg of the circuit connected through the varying resistor, which in this case is a cadmium sulfide or a light sensor, and then going on the other leg we have a permanent resistor, a fixed resistor. In this case, we are using a 10K resistor. Why? Because it turns out you want to have the resistance on both sides of the splitter surface roughly equal, and it turns out that 10K is a good value to put on this resistor. And then out of the middle comes a varying voltage that is going to analog 0 on our Arduino. So as the light shifts in here and we change the resistance, a smaller signal, a lower voltage signal, will be sent into the analog 0 port, and we'll be able to read that and use that to trigger devices. We can, for example, say, as the light goes dimmer, turn on the LED and make it brighter as the light goes dimmer, which we will do in our circuitry. So that is the second circuit that we've covered, and we could substitute, as I said, any resistance device that is an analog in nature. Analog means it's continuously variable, okay? And the Arduino will read that actually as a digital value and give it a number, assign a number to it between 0 and 1024, depending on what the resistance is. So we have analog inputs, and those are the A's, and on the Mega it is A0 through A15, which gives us 16 varying analog inputs. In this case, the analog input is going into A0, because that's what our software is calling for. The third circuit that we're looking at is one that is powered by the high current bus. As you can see, that line comes directly out of the positive of our battery pack and goes down this positive rail. Now we have it entering into the motor control circuit. The motor control circuit runs this little motor on it, which draws quite a bit of current to it, and certainly more than we want to put through the Arduino. It then runs through a transistor, and a transistor is a switch that allows us to turn the motor on and off. And actually, because we run it through the pulse width modulated circuit, we can chop that current and cause it to have less average voltage and control the speed of the motor. So there are two new components in here that you haven't seen before. One is the N-type transistor, and the other one is a diode. As you recall from the LED, diodes allow current to flow through them only in one direction. In other words, if you have the short leg of the LED attached through a resistor to the ground, the current will flow through. But if you have the LED turned around the other way, it won't light up. The same thing is true of this diode down here. We have it, notice that the light colored band is facing the positive rail of the high-powered, of the battery pack rail, the high-powered rail. That's the way it's got to be. So make sure in your circuit that that is not turned around. The silver band or white band on the diode has to face the positive of the high-power rail. What we do is we have from digital 9, we have that wire coming in, going through a small resistor. It can actually be anywhere from 250 ohms up to 1 kilo ohm, 1K, goes into the base, the middle leg of the transistor, sending a signal from the Arduino through this leg, okay, will allow it to control the amount of current that goes through the motor. Okay, the higher the voltage that it goes through, the more voltage will be allowed, the more current will be allowed to come through the motor, and the faster it'll go. And so we have this arrangement. There are 3 pins in a transistor: a collector, a base, and an emitter. And as you can see, the transistor is oriented with the flat side in this direction, and the middle pin then is the base. That is actually where we put the controlling signal. And then the other 2 pins, the collector and the emitter, are where we run the circuit. And notice that the positive power from the battery pack goes into this side, the upper side, and then the ground side, the ground goes into this side. There's the connection to the ground. And remember, it's a common ground on both sides, so it doesn't matter whether it goes to the ground here or the ground there. But the important thing is that you get the orientation, the direction of the transistor correct, so the current will flow through it. If you have it turned around, it simply won't work. Okay, so that's how it works. Notice also that the motor is connected from the high current rail. It's connected directly to that on one side, and on the other side, it comes out on the other side of the diode over here. All right, so, and then it'll work just fine. So what we're going to do now is we're going to end up demonstrating each one of the circuits with the software. Okay, so now what we're going to do is we're going to fade the LED. This is using a sketch or a piece of software called Fade, which is found in the Arduino collection, and it's found under Examples, Basics, Fade. And that's all there is to it. And as you can see, the LED is getting brighter and dimmer, brighter and dimmer. That's because it's sending a pulse width modulated signal from the Arduino, okay, and it's on pin number 9 through the circuit to the LED. And so what it's doing is it's chopping the signal at different rates and sending it to the LED. Now watch what happens. This is kind of interesting. That chopped signal I can send to my motor as well. And watch what happens. It's the same piece of software. I'm just going to unplug it from the LED and plug it into my motor. You can see it's not fading the LED anymore. It's controlling the speed of the motor, because basically a chopped signal is a chopped signal, and whatever you're plugging it into. But the interesting thing is, we're not drawing the power from the of this motor from the Arduino. We're drawing the power from the battery pack. Okay, and I can easily show you that, because if I unplug the battery pack, the motor will stop. Okay, there it is, stopped. Plug it back in. And we're back in business. So that high power bus is definitely running that motor. The only current that's coming through the Arduino is the one that is triggering the transistor down here through this resistor to the base of the transmitter, transistor, the middle wire on the transistor. Okay, and so as I can show you again, that this is not being powered by the Arduino, it's not being powered by the USB, it is being powered by the battery box, because if I disconnect that, it stops. It stops. Now there's still signal going through to the transistor, but since there's no current going through the high power bus, the motor isn't working. Okay? That's it. So now we've used Fade for both of those things, and we can go and take a look at some of the other stuff. Let me just put it back the way it was. And let's power it back with the LED again. But in this case, now we've got it through to the LED, you can see that this signal is actually coming from the Arduino. It is not coming from the battery pack. It's coming from the Arduino, and I can show you it's coming from the Arduino because it's coming through the wire connected to pulse width modulated pin number 9, and watch what happens if I unplug my high power bus. Note that it still works. Okay, we are drawing power through the USB bus to the and through the Arduino. That's the nice thing about the high power bus. It gives you safety protection from burning out your Arduino or your LED or whatever device you're powering, because you really don't want to put any more than really, if you keep your maximum at 100 milliamps or less, you're going to be just fine. Okay, so now what we're doing is we're going to look at a piece of software called Analog Read Serial, because what we want to do is we want to be able to look at what the light sensor, the cadmium sulfide cell, is doing. Okay, and so what I have to do is I have to focus on the screen a little bit, and we'll see what happens. We have found this piece of software, and this is called Analog Read Serial, which is in the basic section of the Arduino. Okay, and so what I'm going to do is set the camera up so you can see my screen. Here's the cadmium sulfide cell, and one leg of it is connected to the ground, the other leg is connected to this circuit, which then passes through a 10K ohm resistor, and this is a voltage divider circuit, so the divided voltage comes out of there and goes into analog 0, okay, on this particular piece of software. And now let me open the serial monitor by clicking on the serial monitor box in the upper right hand part, and there we get the serial monitor readings, and as you can see that they are reading in the range of 190, 191, and if I turn the light on, hopefully that won't expect so, but you can see that the readings now drop down. The lights are on, it's dropped down to 70, 71, 75, okay, and if I were to put it anywhere in the middle, what I'm doing is just taking it, blocking the light off with a piece of paper, and you can see that the figures change, the readings change as we go in. Now if we replace the CDS cell with the thermistor is much slower to respond, but it would do basically the same kind of thing. Okay, now what we've got is a piece of software that is found on our web page. It's not in the Arduino collection, and it's called Analog in PWM Out Serial Lesson 2 EM Modified. Okay, and this is just a piece of software I messed around with a little bit, and you can see what it does pretty easily. And so what I have done is it has a PWM connected from pin 9 to the LED, and the CDS cell is connected through a voltage splitter arrangement to analog 0. It's pretty much the same as we've had in the past. But let's load this piece of software in. And there it goes. And it's now in. And let's see what happens. Now, it should... Watch what happens as I block the light. See the LED get brighter. So as the light goes down, the LED dims as the light gets brighter, and as the light goes down, it gets brighter. I can do that by switching the light on and off. Okay, watch the difference in the LED brightness. Okay, and now it works that way as well. But let's see, I'm going to take that, and I'm going to take that PWM out and put it into my motor. Why not? Okay, so here we go. We're going to take it out of there. And remember, my motor's running on the high power bridge. Okay, and let's see if we can get this to function. Turn the light off, and the motor starts. Turn the light on, and it stops. And we can change the motor speed by changing the amount of light. Enough light goes in, and then if we bring it in, okay. Now, of course, one of the things you could realize is that we don't have to be running the motor from it. We can change the any of the variables in the software, but we can also put a thermistor in there instead of the CDS light cell, and that would mean the temperature could trigger the motor. Well, if you've got a fan motor and you're running a fan, you could have the temperature turn on the fan when the temperature gets too hot, couldn't you? Pretty easy. You can have it vary as well, so that if it gets hotter and hotter, the fan goes faster and faster, just as it did with the LED. Okay? So let's go switch it back. We'll put it back so that it's running off the Arduino and running the LED. And bingo. So now we've got the LED, again, the LED getting brighter as the light goes down. So the light is on now, and we can dim that, and then as we start blocking the light, it gets brighter and dimmer, brighter and dimmer. Okay, that covers it, and we pretty much covered everything we have for all of these lessons. Okay, bye.